Yeah, right. So, so now introduction to the H01 architecture. I think any embedded system required on my program build device. So right now we are discussing with the 8051 microcontroller. So next one, sorry. So microcontroller, a basic question in your mind, right? So what is microcontroller? So a small computer system. So you develop any system, you are using any microcontroller to do the some arithmetic and logical operations. The system is called a system, computer system. You do something operations, right? So that's why microcontroller is a small computer system, right? And next on chip RAM, ROM, IO ports. Remember, so it requires RAM to access the internal memory or external memory to maintain the some memory ROM, and next one is some IO ports to face the some IO components and some for communication protocols. So these are the basic thing you required in microcontroller. So we are the human being, right? What do you have? So some hands is there, some body is there, some right select something like same way we have some minimum things to the your selected device, that is RAM, ROM, IO ports. So give us some example, microcontroller based some manufacturing companies, Motorola, Intel, Xerox, and Pika. These are the basic uh, introduce the edges for introduce companies. These are right. So what are the major blocks inside the microcontroller? So my first thing is the CPU, the processing unit, and next RAM to access the memory, ROM to store the data, IO ports to communicate, to interface any other components to collect the informations, timer to do the to provide the time related info operations. Next one, communication port. Six ports involved in the microcontroller. It is a three different, six different blocks on a single chip. That is called a simple microcontroller. So these are all are available in 8051. It is a basic microcontroller. So before some memory microcontrollers is there, but it is standard one. Here it is 8-bit one. Before microcontrollers are 4-bit ones, right? It is a 8-bit, and first microcontroller is 8051. So what is the difference between the both? We have no. I think all are know the two things: microcontroller, microprocessor. What is the difference between both? So in microcontroller, all whatever you to interface externally to the microprocessor, like RAM, ROM, IO ports, timer, these are all are inbuilt inside the microcontroller. So that is basic difference. So the basic difference is all are these are RAM, ROM, IO ports, timers, and serial port. All are in inside the chip. Inside the chip, that is a microcontroller. You add externally. You add externally. That is the microprocessor. Physically, that is the main difference. Is it clear? Is it clear, guys? Yes or no? That is the main physically small difference. Is it? This is the difference. The required any required things are external. You add to the external. That is a microprocessor. So these are all on a single chip. That is a microcontroller, right? So these are all are inside the microcontroller. So it have a limited. It have a limited. So there is no chance to action the this. But in the result, we action the RAM, ROM, and IO ports and timers. These are external things, right, guys? Is it clear? Is it clear? That is the basic difference. Is it clear or not? So most members have the same doubt also. So what is the difference between both in physical relation, physical device difference is that is you add the external RAM that is in your PC, ROM, externally hard disk, IO ports, different ports, exchange ports is there. Timers that is also inbuilt. to provide the clock signal purpose. And communication port, different VGA cables, HDMI cables, these are external cables, right? Those are the external ports. So these are external. What are the components? These are external. So that is a microprocessor. These all are the inside the chip. That is a microcontroller. That is the basic difference between the both. Is that clear, guys? And next thing. So what is the major difference between these? Are all the same difference. So if you stand it alone, so because CPU is inside the microprocessor, right? If you have only CPU, so remaining everything is outside in microprocessor. So in microcontroller, all are on the single chip. All are on single chip. The next one is, so you build a microprocessor relation systems. That is your choice. Extend the RAM and ROM and IO ports. But in microcontroller, these all are fixed. These are fixed. So compared to microcontroller, it is expensive based on the cost. It is a microprocessor expensive because of it. They have a lot of application you use it to during the attack time things. So that's why it is expensive. It is compared to the microprocessor is very cheap because it is available in market around 100 rupees. Is it clear? So it is a general purpose. It is a single purpose. So it's a multi-purpose. Microprocessor doing multi-purpose based on your requirement, but microcontroller is doing only one work. Is it clear, guys? And next one, these are the 8051 family microcontrollers, and these are some difference. So what is the ROM, what is the RAM, what is the timers, IO ports, serial ports. Serial ports means communication ports and interrupts. So these are small difference, but 8051 is the main thing here because of they have a advanced some compared to this, they have same characteristics. Very popular one, 8051, right? So, we enter the features of 8051. What are the features of 8051? Before using any microcontroller, before using to develop any system, so you need a microcontroller first thing. And the second thing is which one is suitable for your project. Okay, which one is suitable for your project. So you must know the some features related to the microcontroller. So the 8051 features is 4 KB ROM. 4 KB ROM, 120 bytes of RAM, 4 IO ports. 4 IO, each port have 8 pins. Remember things, guys? We must use this only in the entire workshop. We are using these IO ports. So clear? So clear, guys? The next two timers and one serial interface. And next one. So it is capable to extend the memory 64 up to 64 KB. And same data memory and external source code also. Right? So these are the basic features of 8051. So before design, you must know that this thing, it is sufficient for you or not. Take once. So the microcontroller block diagram. It is a blocks. What are the blocks inside? The first one is to provide the timing. To provide the timing related to operations using oscillator. It will provide the clock signal to the inside the microcontroller. So next one is a ROM block. So random access or read-only memory. So inbuilt some internal instructions is there. So next one is the RAM. Next one is 16-bit timers. So here timers we are using two ways. So for delay purpose, for internal operations, you are using delay purpose, and external events count as a counter purpose. Next, CPU of 8051. So what are the relation operations is inside the microcontroller. Next is 64 bytes of external memory. So suppose you need external memory, so interface to the microcontroller. Next, 4 IO ports, each port have 8 pins. Just programmable IO pins. So programmable communication protocol. So serial and a zero. This is the basic blocks. What are the blocks inside the microcontroller? We are using all our in our internship. Next one, this is the pin diagram of 8051. So observe the 8051. It have a, I think all are know it is have a 40 pins. So in 40 pins, 30 pins are IO pins. So IO means input output pins. So you can use either input or output. So these out of the 40 pins, so 24 pins of dual purpose, because the remaining pins are 8 pins, remaining 8 pins, only IO pins. But remaining 24 pins are dual purpose. To use IO pins and some special operations is there. So not related. So ports of 8051 totally it have a 4 ports. So port name, port 0, port 1, port 2, port 3. And port 2 is the dual purpose. Port is the dual purpose. So up here, the pin diagram of 8051. So it is a port 0, right? So right side is a port 0. Observe is a AD0, AD1. Mention the AD0. AD means address. D means data. So here the 8051 of address bus is 16-bit size. So lower 16 lower lower 8 bits in port 0 and remaining 8 bits in port 2. Remember one thing, guys. Address size is 16. So in 16-bit size, lower 8-bit are in port 0, multiplexed with the port 0, and the higher order of byte 8 pins is multiplexed with the port 2. And same way, in port 0, one more pins is there. Data bus pins also combined with the port 0. That is the mention the AD. So either using address line or data line in port 0. First of all, you are using port 0. First of all, you are using to interface any IO component to the microcontroller. So you require pull-up registers. So in this case, first of all, you choose IO pins. So the pin is acting as a open drain configuration. So in open drain configuration, first of all, you are using IO component, IO
I made
interface. You must add the pull-up registers to the pin of whatever the pin you use. The add pull-up registers to the particular pin. So remaining pins information, totally 4 ports. Any port, each port have 8 pins. You can access any 8 pins, but suppose you are using port 0, you must use the pull-up register to using the IO operation purpose. So port 3 also dual purpose. Each pin have a individual works. So over here, port 3 is the, so here have some of the pins is there, port 3. So port 3 have multiple individual pins, individual operations is there. So 08 pin, RxD pin, 1 pin, TXD pin, INT0 interrupts. These are 2 are interrupts pins. Remaining 2 pins for external timer and next 2 pins for read or write of external memory. So that's the 8 pins. Remember, guys? First 2 pins for serial communication port pins, RxD, TXD. Next 2 pins external interrupts, INT0, INT1. Next 2 pins for a timer input for counter operation purpose. Next 2 pins for read or write the external memories. The remaining 2 pins. So these are those things. So RxD, TXD. So alternate operations of the individual pins of port 3. So timers and counters. So you give the brief introduction about the timers and timers concept, guys, but you give the small information. The 8051 has 2 timers. So timer 0, timer 1. The timer using internal clock, that is a timer. Or suppose the timer using external clock, that is a counter. That is the main difference. A timer or counter. You call the timer and counter. So what is the timer? What is the counter? Okay. So suppose you are using internal operation, internal, you can use the internal clock, that is a timer. But suppose you give the source X source to the
here.
timer. So that is the counter. Guys, please respond. Any issue? Right, guys. So what are the registers to control the timers operation? I will explain this the timers concept, guys. Don't worry. So in first day, some disturbance. So what is the timer? What is how to use this one?
Sir,
Yeah, okay. Raviteja, what is the problem, Raviteja?
సార్ మీ వాయిస్ బ్రేక్ అవుతుంది.
Break అవుతుందా? Okay. So right now is fine, guys. Right now, why is clear or not? Just give me confirmation. Okay, thank you, guys. So I'll explain the timer related operations and then the two sections. Don't worry. So you do the some examples on the timers counters operation also. Don't worry. So symbol of 8051, guys. It is a 40 pin IC. So the for each port have a observe here 40 pins. First pins are port 1 and remaining some external pins is there. And then after port 3 and the right side port 0 and port 2. So how to give the power supply to the 8051? So for internal operation purpose required 5 volts of DC. 5 volts of DC. So it is a block diagram how to convert the AC to DC. Right? So here using a bridge rectifier to convert the AC to pulsating DC. Then after maintain the filter section to remove the ripples of converted DC. To maintain the constant output, we are using voltage regulators. Then after to maintain the remove the ripples, we are using again filter section. Then after the power supply is given to the microcontroller. So here three blocks is there. First one, to convert the AC to DC, you must use the rectifier circuit, any type of rectifier. So bridge rectifier or converter tab something. We have a three different type of rectifiers, right? First one is a bridge rectifier, full wave, and full wave center tap rectifier is there, and half wave is there. Totally three different type of rectifiers. So once you convert the AC to pulsating DC, what is the main use of rectifier, guys? What is the use of main use of rectifier? It converts the phase of the cycles. So AC is the alternate cycles, right? Positive off is there and negative off is there, right? To convert the phase conversion of the signal, we are using rectifier circuits, right? So output of the rectifier is only single phase, only positive phase is there, right? So it has some lag points. To remove those ripples using filter section, right? So to remove the ripples, we are using filter section. So once you remove the ripples, then maintain the constant voltage. To maintain the fixed voltage, that is 5 volts, required voltage is 5. So to maintain the fixed voltage, so using regulators. So after the regulators to remove any pulses, any ripples is there, using you need capacitor based rectifiers, capacitor based filter circuits, remove the unwanted ripples out of the regulator. So after that, we given the directly given to the microcontroller. So this is the power supply diagram of required power supply conversion block diagram. So this is a small information about 8051, guys. It is a small information about 8051. So if you have any doubt, guys, please write in chat box. Please respond, guys. Any doubts? So before interfacing any IO component to the microcontroller, we must know the what are the pins that are available to interface your devices, right? So that's why I give a small information about microcontroller. What are the blocks? What are the pins? And how to behave the microcontroller. That is the basic information. That's why I give the basic information to the you. So if you have any doubt, please again. Okay. So in a home requirement is AC voltage, but our microcontroller requirement is 5 volts of DC, right? Yes or no? That's the main thing. So the household supply is available 230 volts, right? But our microcontroller requires 5 volts. So how to convert the 230 volts AC to 5 volts of DC? To convert the AC to DC, to convert the AC to DC, so some steps is there. Those steps are, the first thing is to minimize the amplitude of signals, because of the AC signal have a around 230 to 292 to 240, right? Of amplitude, right? So to minimize that, we are using transformers. So the transfer input is AC and the transfer output is also AC. But it reduces the magnitude of amplitude of the signals. The next thing is to convert the phase conversion. Every AC signal have a two phases of positive phase is there and negative of phase is there, right? For to convert the phases, we are using rectifier circuit. So once you're using the rectifier circuit, the output of rectifier circuit only one phase is, so positive phase is there and negative off is converted to the positive phase. Okay, guys, but it have some pulses is there. So this means it is constant magnitude. Constant magnitude. 5 volts is fixed the 5 volts. The draw the straight line. But after the rectifier circuit, it is a simple like cloud type, some ripples, some signals. Okay. To remove those ripples, you are using a filter. You can use the filter. So to remove the filter, to remove the ripples, right? So ripples signal is called pulsating DC. So once you remove the ripples, so that is a pure DC. That is a pure DC, but it required 5 volts DC. The output of the filter circuit is more than the 5 volts. I think any type of transfer, give the output is more than the 5 volts. To maintain the constant voltage, you must use the regulators. So it regulated maintain the constant voltage. What you give the input, based on that you maintain the constant voltage. So the output of regulator is any ripples, for example, any ripples coming. So it just remove purpose, we are adding again filter. So the block diagram, power supply block diagram of required 5 volts DC. Is it clear, guys? Yeah, thank you, guys. Give me 2 minutes of time, guys. I'll explain some important point of my pins, each pin. I think everything is fine. Okay. There is no doubts regarding the small information about 8051. So before interfacing to the any component to the microcontroller, so you know the some basics like, so what is the capabilities of IO pins of 8051 and what are the required capabilities of IO component? For suppose you are interfacing any component to the microcontroller. Suppose it is an input component. First identify the component. It is input component or output component. So first of all, this is the output component. What are the requires? Requires means so required voltage and current. Suppose you drive any component, that is output component. Drive component means output component. So you drive any component. So what are the requirements to control those components? Okay, first you know the what is the requirements. For suppose you give the example LED. So LED is the output component. What are the requirements to the LED? So it's required. So some current to some required qualities. 5 volts or 4 volts of voltage and some current requirement. So we given the microcontroller is given the same or not. So the requirements did fulfill the requirements of our component. So first one is you know the basic thing. The microcontroller pin is capable 5 volts, operating in 5 volts. But suppose so the it is a digital pins. The whatever the pins have, edge one having those are digital pins. You do the digital operations. So in digital operation, two states is there, high or low, or logic one and logic zero, right? So in logic one, it give the 5 volts of DC. It capable to give the 5 volts of DC. In low condition, it give the 0 volts. Remember this, guys. In voltage representation, it capable to give the logic one in logic one, it give the 5, and logic zero, it gives the 0 volts, right? And same time, okay, at same time, it give the current is 5 milliamperes. Remember that, guys? 5 milliamperes of. Suppose you it capabilities is given current IO component is 5 milliamperes. At the same time, you are suppose you are using the pin is input component. For suppose you think it is input component, so it taken 10 to 50 milliamperes of current. Is it clear, guys? This is the basic information. Suppose you interface any component to the microcontroller. So the information exchange between the both components in the voltage and current format, right? Yes or no? Just give me confirmation. The information exchange between two components, microcontroller IO component, in the form of voltage and current. Yes or no? Did you understand the point? Did you understand the point? Yes or no? So just give me confirmation, guys. You are under not, I think. Right. Any information exchange between the microcontroller IO components, you must know the what is the capabilities of microcontroller. Or suppose you directly give it to the microcontroller pin. What happens? The microcontroller pin is burned or breakdown. Is that no? It's not working because of the capability is 5 volts only. And if suppose if that pin is actually using input pin, it required it is capabilities to take in 10 milliamperes to 50 milliamperes current and 5 volts only. Is it clear? First of all, so you are using output component. These capabilities it given 5 volts of current, 5 amperes of current, and 5 volts of voltage. Right, guys? Yes or no? Did you understand the point or not? Did you understand or not? The capabilities of addition is over. You are understand or not? Correct. So first you know that these main important points. What are the capabilities of 8051? Capabilities of 80 pins, individual pins and go. And same thing, what are the requirement to operate the OA component? So you are add interface any output component. What are the required components? What are the required to operate particular component? So what is the required voltage of LED? I think most of members are used in our lab work in the lab. LED related operations, almost all are doing some LED related programmings, right? As in IoT lab or embedded systems lab, some digital operations we are doing some LED operations, right? So what are the required input of LED? What is the required input of LED? Anyone, guys? Anyone, please? What is the required input of LED? Active high. So, some members say active high. What is the meaning of active high? I'm asking what are the required inputs of LED? Basic input. Only two formats, voltage and current. 3 volts, some members given 5 volts, okay, good. Right. So here one doubt is there. So which color? Which type of color? So many different type of LEDs in market, right? Red, green, yellow, white. I said no. I said no, guys. So based on the color, so it required voltage input required voltage is different. Remember it, guys. Based on the color, a required input is different based on the color. So remember these points, guys. So red color requires 1.8 volts to 2.2 volts. For conducting purpose, required 1.8. For maximum voltage is 2.2. Remember thing, guys. Hello, 2 volts to 2.2 volts. Green, 2 volts to 3 volts. Blue, 2 volts to 3.5 volts. White, 3 volts to 3.5 volts. So in worst case, requirement is 1.8 to conducting purpose. So worst case, some of the different colors is there. Okay. Did you understand, fine, guys? So required voltage of a LED based on the color. So once you give the 0.7, the LED is coming from connecting. Okay, just connecting. So to require maximum glow, is give the based on different voltages. So the microcontroller output pin is gives the maximum 5 volts, right? But LED requirement is worst case is 3.5 volts. Is it clear, guys? Worst case maximum voltage is 3.5 volts. And next thing, guys. So any type of LED is required 10 to 20 milliamperes of current. It required 10 to 20 milliamp current. So for safe zone, it required 10 milliamperes is sufficient. 10 milliamperes of current is sufficient. So remember thing, guys. First thing, so for suppose you choose the IO component is LED and the LED color is red color. So the red color LED requires 3.3 volts to 3.5 volts. It requires 3 to 3.5 volts, and every LED required current is for safe zone 10 milliamperes current. But the microcontroller gives the 5 volts of DC, and the current is 5 milliamperes of current for output pin. For suppose they are using the input pin, it required current is a cable to take in the current is 10 to 50 milliamperes of current. Please note this important point, guys. This requirement is there. Suppose you develop the any project, so the max power limit, you might know the power limit to use the adapters are converted to maintain the required supply. Okay, that's why I'm telling this important point, guys. So you interface any component to the microcontroller, you must know the required things in voltage and current. What are the requirements? So I think all are understanding my point. So capabilities of microcontroller and requirements of LED. Both is completed. Before interfacing the component, you must know these things. Required voltage, required current. Capability of voltage, capability of current. Did you understand the point, guys? Did you understand the point? Yeah, right. So, so my question is, so the capability is more than the requirement, right? The capability is more than the requirement. So that situation, how to handle the particular situation? The capability of a microcontroller is 5 volts, right? But requirement is 3.5 volts. Yeah, right. How to drown the voltage? How to drop the voltage? Hemant Kumar, good. Remember, person, guys, give me any suggestion to the drop the voltage. Any suggestion to drop the voltage? More bulbs. Yeah, my application only interface just a single LED. Okay, resistor resistance. Okay, good. So, what is the value of resistors? In market, so many different types of resistors is there. What is the value of resistor? How to find out the resistance, required resistance? You find out, you guys. You find out the resistance value. So, what is the formula? How to find out the resistance value? You found out that. Oh, you find the value. Yeah, okay, R equal to V by I. Okay, good. What is the resistance value? What is the voltage? What is the current? Mention that point also. 5K maybe. Okay, you guess the 5K. There is no guessing options is there. There is no guessing options, guys. You find the required resistance. How to find the required resistance? That is the main thing. So you find the required resistance value. V equal to 9 volts. Remember one thing, guys. The IO capabilities of capacities only uh, microcontroller is 5 volts. You mentioned the 9 volts. 3.5K. There is no guessing options, guys. You must mention the find out the value, exact value. So V equal to 3.5 volts, I equal to 50 milliamps. Then 50 milliamps of current is required to the glow the LED. No, only 10 to 20 milliamps of current is sufficient. Okay. For safe operation, it required 3 amperes is sufficient. So, for example, you are using red color LED, it requires 2 volts only. 2 volts of input and 10 volts, 10 milliamperes of current. So, now find out the resistance value. No, 2 km, no, 175 ohms. Okay, good. So, required voltage is 2 volts, right? So, actual voltage is 5 volts. So, 5 separate with 2. The difference between the 5 to 2 is 3 volts, right? So, 3 volts by 10 milliamperes. 3 volts by 10 milliamperes. So, what is the resistance value? What is the resistance value, guys? So, remainder is 10 millis, right? So, millis in the top row, 3 into 1000, 3000. So, 300 milliamp, 3000, sorry, 300 ohms of resistor. Yeah, right, good. 3 ohms is sufficient. No, no, guys, only 3 volts. Okay, I will tell you on that. So, I will explain how to calculate the resistance value. Give me a minute. So to find the required resistance value, so R equal to V by I. This is the basic formula, right? So for to find out the V, so V is the capable of input voltage of required maximum voltage of component VF, and next by I. So, okay, na? So V is the 5 volts. V is the 5 volts. So forward voltage of component is 2 volts. Maximum voltage is 2 volts for red color. So I is the for safe operation purpose 10 milliamperes. Remember, guys? So 5 minus 2, 5 minus 2 volts is given the 3 volts, right? So 3 by 10 milliamperes. 10 milli. So 10 millis means millis means 10 to the power of minus 3, right? 10 to the power of minus 3. So it moved to the top wave, I mean numerator. So 3 into 1000. So multiply with the 1000 because of the 10 to the power of 3 is the 1000, right? By 10. So 0, 0. So required volt resistance value is 300. Are you clear, guys? Are you clear? Are you understand or not? How to calculate the required resistance value? Give me confirmation, guys. Did you understand the point or not? So around 400 members are attending the meeting, but give me the sum. Only few members are giving the reply. Okay, you're right. That is a way to calculate the required resistance value. Okay, guys. Thank you. So before interface any component to the microcontroller, you must know these steps. You can add input component or add output component. So requirements you must find the requirement. Yeah, good. I think yesterday I will explain how to create the process on the Hill and Proteus, right? So our first concept, guys. Yesterday I already told you the basic project. So right now I'm using main first project. That is to blink the LED. It is an example how to use the IO pin as a digital operation. Because what are the pins we have? All pins are digital pins, right? All pins are digital. So, okay, guys. I think all are understand how to create the projects on Proteus and Keel. You must follow the steps. Some shortcuts is there, but this is the main basic way to create the projects. Is clear, guys? So now I'm explain the steps again and create the projects in Proteus and Keel and complete the first topic. The first topic is to blink the LED. So our agenda is just you blink the LED. Just blink the LED. So we complete the basic requirements. First of all, you introduce the LED. What are the requirements? So we require one more component, that is LED. Okay. First of all, you buy the any component from outside to build the any project. You must know these steps. It is a simulator. There is no add the register value between the LED and microcontroller. It is a simulator, right? That's one more thing, guys. First, you find out to rectify the drawback. What is the drawback? The required voltage is 3.5 volts or 2 volts. Sorry, 2 volts. But microcontroller cap voltage output voltage is 5 volts. So to avoid to protect the LED, you must add the resistor, right? You add the resistor to protect the LED. Yes or no? Yes or no, guys? Guys, please respond. Yes or no? To protect the LED from microcontroller, you must add the resistor. So how to connect the resistor? How to connect the resistor? So something basic questions. How to connect the resistor either series or parallel? We're talking about the voltage drop, right? We're talking about the voltage drop. So voltage drop in only series. Yes or no? Drop is always in series. Voltage drop in only series, right? So in series connections, how to connect the resistor? Because the LED have two terminals. So which terminal is added to the resistor? So what are the terminals names of LED? What is the names of LED? Anode and cathode, right? Anode plus indication, negative indication is the only supply purpose only. So here I will mention the anode and cathode only. Okay, guys? Yes. Anode and cathode. So in series connection, you resistor added to the anode or cathode. Anode or cathode. Which one? Anode. Why? What is the reason to add the resistor to the anode terminal? What is the reason? Guys, please respond. Why you are connected to the anode? So forward connections, okay? After you connect the resistor value in cathode terminal, what happened? What happened? Clearly, I will explain in Telugu also. Give me a minute of time. So resistor అనేది యానోడ్ కి కనెక్ట్ చేయాలా క్యాథోడ్ కి కనెక్ట్ చేయాలా ఏంటి ఇదను ఎక్కడ ప్లేస్ చేయాలి సో యానోడ్ ప్లేస్ చేస్తే ఏంటి రీజన్ క్యాథోడ్ దగ్గర ప్లేస్ చేస్తే ఏంటి రీజన్ నాకు కావాల్సిన రీజన్ అండ్ వై ఎందుకు యానోడ్ దగ్గర కనెక్ట్ చేసుకోవాలి వాట్ ఈస్ ద రీజన్ టు కనెక్ట్ ద ఎల్ఈడి సారీ resistor value to the resistor to the anode terminal. What is the reason? I think both connections will be right off. Okay, good. Both connections are okay, good. High potential at the anode side, right? Current flow through anode in LED. Who is a Nagul, I think. Current entries from positive terminal to negative terminal. Good, guys. So to create a main agenda is to protect the LED. To protect the LED. So ఎవరి నుంచి ప్రొడక్ట్ చేయాలి ఎవరి నుంచి ప్రొడక్ట్ చేయాలి ఫ్రమ్ ఇన్పుట్ సైడ్ నుంచి రైట్ ఫ్రమ్ ఇన్పుట్స్ యూ ప్రొడక్ట్ ద ఎల్ఈడి సో ద కరెంట్ ఎంట్రీ ఫ్రమ్ పాజిటివ్ టెర్మినల్ only two terminals so and the resistor is added to the anode ఓకేనా మనకి ఏంటంటే ప్రొడక్ట్ చేయాల్సిన వాళ్ళు లో ఉండాలి ఎంట్రీకి ఫ్రంట్ లో ఉండాలి బ్యాక్ సైడ్ ఉంటే ఎవరిని ప్రొడక్ట్ చేస్తున్నట్టు ఎల్ఈడి అనేది రెజిస్టర్ ప్రొడక్ట్ చేస్తున్నట్టు అదే రెజిస్టర్ ఫ్రంట్ లో ఉందనుకోండి రెజిస్టర్ అనేది ఎల్ఈడిని ప్రొడక్ట్ చేస్తున్నట్టు Point clear అండి? Yes sir, no. You are using a resistor to protect the LED. So you must add the resistor anode terminal because the current flow from anode to cathode. So to control the flow, current flow, right? You are using a LED, you are resistor to control the flow of current, flow of electrons, right? The electrons entering into the anode to cathode. So that's why you're using the resistor to connect to the anode terminal. Say yes or no. మీకు అర్థమైంది అర్థం కాలేదా? సింపుల్ థింగ్. Yes or no, guys? I'm waiting for your confirmation. No. రైట్ అన్నా, మనకి క్లియర్గా తెలుగులో కూడా చెప్తాను వినండి క్లారిటీగా. మైక్రో కంట్రోల్కి వచ్చేపాటికి అవుట్పుట్ అనేది 5 volts వస్తుంది ఎట్ లాజిక్ 1, 0 volts వస్తుంది ఎట్ లాజిక్ 0. బట్ మీరు చూస్ చేసుకునే ఎల్ఈడి ఏదైతే ఉందో ఆ ఎల్ఈడి రిక్వైర్మెంట్ బేస్ కలర్ బేస్ చేసుకొని డిఫరెంట్ వోల్టేజెస్ ఉన్నాయి. సో మన రెగ్యులర్ గా అక్కడ కామన్ కనిపిస్తుంది రెడ్ ఎల్ఈడి కాబట్టి, సపోజ్ రెడ్ ఎల్ఈడి తీసుకున్నాం అనుకోండి, లేదు మీరు ఏ కలర్ కావాలంటే కలర్. ఆ ఎల్ఈడికి కావాల్సిన రిక్వైర్డ్ వోల్టేజ్ ఉంటుంది, ఎంత వోల్టేజ్ వరకే ఇవ్వాలి, అందుకన్నా ఎక్కువ ఇస్తే కనుక అది బ్రేక్ అయిపోతుంది. సో నా సజెషన్ ఏం తీసుకున్నా నేను రెడ్ కలర్ ఎల్ఈడి తీసుకున్నాను. రెడ్ కలర్ ఎల్ఈడికి మాక్సిమం వోల్టేజ్ 2 volts ఉండాలి. మాక్సిమం వోల్టేజ్ 2 volts ఉండాలి. సో 2 volts కావాలి, కానీ ఇక్కడ ఇన్పుట్ ఉంది 5 volts ఉంది, బట్ ఇక్కడ రిక్వైర్మెంట్ ఎంత ఉంది, 2 volts ఉంది, రైట్? సార్ నో. And it required current is 10 milliamperes. LED required current is 10 milliamperes. It is capable to drive the microcontroller, capable to drive 5 milliamperes. అర్థమైందినా? క్లియర్నా? ఇక్కడ మనకి హై వోల్టేజ్ ఇస్తున్నాం, ఎవ్రీ కాంపోనెంట్ హై వోల్టేజ్ డిపెండెంట్, రైట్? ఇక్కడ మోర్ వోల్టేజ్ ఇస్తున్నాం కాబట్టి ఎల్ఈడిని ప్రొడక్ట్ చేయాలి. ఎనీ ఫ్లక్చుయేషన్ వచ్చింది అనుకోండి, హై వోల్టేజ్ వస్తున్నాయి, హై వోల్టేజ్ వస్తే ఏం చేయాలి, కాంపౌండ్ ని ప్రొడక్ట్ చేయాలి. కాంపౌండ్ ని ప్రొడక్ట్ చేయాలంటే కనుక ఏం చేయాలి, ఇక్కడ కంపల్సరీగా మనం డ్రాప్ ని క్రియేట్ చేసుకోవాలి. అంటే ఇక్కడ 5 volts కన్నా ఇక్కడ ఎబో వస్తుందా, 5 volts కన్నా ఎబో రాదు. సో 5 volts వస్తుంది కాబట్టి అందులో ఏం చేయాలి, దాన్ని కన్వర్ట్ చేయాలి. ఎంతగా 5 volts to 2 volts గా కన్వర్ట్ చేయాలి. అంటే 5 volts to 2 volts అంటే ఏం చేయాలి, డ్రాప్ ని క్రియేట్ చేయాలి. డ్రాప్ ని క్రియేట్ చేయాలంటే కనుక రెసిస్టెన్స్ ని యాడ్ చేయాలి సిరీస్ లో. సిరీస్ లో రెసిస్టెన్స్ యాడ్ చేస్తే ఏమవుతుంది, వోల్టేజ్ డ్రాప్ అనేది క్రియేట్ అవుతుంది. సో రిక్వైర్డ్ వోల్టేజ్ అనేది ఎల్ఈడికి వెళ్తుంది. సో ఈ రెసిస్టర్ అనేది యానోడ్ కనెక్ట్ చేయాలా, క్యాథోడ్ కనెక్ట్, ఇంకా డౌట్ ఉంటుంది. యానోడ్ కనెక్ట్ చేస్తే ఏమవుతుంది, క్యాథోడ్ కనెక్ట్ చేస్తే ఏమవుతుంది. సో ఇక్కడ రెసిస్టెన్స్ ఎందుకు యూజ్ చేస్తున్నాము, ఎల్ఈడిని ప్రొడక్ట్ చేయడం పర్పస్. ఎల్ఈడిని ప్రొడక్ట్ చేయాల్సిన వాళ్ళు ఎక్కడ ఉండాలి, ఫ్రంట్ లో ఉండాలి. ఫ్రంట్ అంటే ఏంటి, కరెంట్ ఎక్కడి నుంచి ఎంటర్ అవుతుంది, యానోడ్ కి ఎంటర్ అవుతుంది, క్యాథోడ్ కి ఎగ్జిట్ అవుతుంది. సో ఎంట్రైడ్, సో ఎల్ఈడిని ఎక్కడ కనెక్ట్ చేయాలి, ఎంట్రింగ్ పాయింట్ లో కనెక్ట్ చేయాలి కాబట్టి రెసిస్టెన్స్ వాల్యూని యానోడ్ కి కనెక్ట్ చేసుకోవాలి. ఇది దాని యొక్క మెయిన్ టాపిక్ నాన్న. ఇప్పుడు మీకు అర్థమైంది అనుకుంటున్నాను వాట్ ఈస్ ద యూజ్ ఆఫ్ రెసిస్టర్. సో ఐ కనెక్ట్ ద రెసిస్టర్ ఇన్ బిఫోర్ ఎల్ఈడి. Still you have any doubt, write in chat box. What you have in doubt, just put in the message in chat box, guys. Please respond. All of you, please respond. You have any doubt, just give me your doubt. Otherwise, give me confirmation. It's okay, clear for you. Okay, guys. So right now we are using simulator. So there is no need to connect the LED, but in real time, you must add the some resistance value to product the LED. So now I completed the topic, that is interface an LED to a microcontroller. Today our main agenda is just interface an LED to the microcontroller and bring the LED. So that is the main agenda, right? So to complete this topic, so to create the projects on the Proteus and the Kill. So how to create the projects? Remember thing, guys? I mean, important point. So to practice purpose, I will explain again. First thing is, just observe here, guys. For creating a new project, just click on the file menu and select option new project. It will take around 10 to 20 seconds of time to initialize the project. So in first wizard page, this is the first wizard page. In first wizard page, you give a suitable name to the project. This is a project name, right? So you give the only name. You give a name to the project. So I will give the name to the project is LED underscore blinking. LED blinking. And next set the path where you want to save the project. So my destination is in desktop, right? So I'm set the path. So move to the desktop. In desktop, we create the one more folder. So project, this is the project folder, guys. So one more here in the new folder and rename the folder name is blinking LED. So it is a serial one. So first topic, that's why I mentioned the one. So concept name LED blinking. LED blinking. So select that folder and check the path and the project name. So it is everything is fine. Just then after, just click on the next. So second wizard page is related to the CEMEC design. We are using only one purpose only. That is the hardware simulation purpose. Here not create the schematic, not design the PCB, not develop the firmware. So this software using totally four different types, four different purpose. So simulation purpose, schematic design, PCB design, and firmware development. But we are using only simulation purpose. So no need to create the any schematic design. So select that, do not create the schematic design and just click on next. Then after, no need to create the PCB for this project. So initially this one is selected, just click on next. Same way, no final project, right? We are only using for simulation purpose. Just click on next. So finally, you show the summary information about your project. So this is the path. So there is no schematic design and PCB design and firmware development. We are using simulation purpose. It will give the details about our project. Finally, click on the finish. So once you create your project is open the two different tabs. This is a simulation and next one is the PCB design. So in my point of view, you are using simulation purpose. So that's why you click on the ISI symbol for simulation purpose. So once you click on that, you do the first thing. Required components added to the device list. First thing, basic thing is what are the required components for your project or to your project, your topic. First, those components are added to the device list. So this is the device list. This is the device list. It is a overview window. It is a design sheet. So there is no component in device list, right? So you freshly added the required components to this list. So required components, what are the required components, guys? First one is the microcontroller and second one is what is the second one? LED, right? So these are all available in component mode. The LED and microcontroller, both are available in component mode. So that's why I'm selecting the component mode. So once you select the component mode and just then after we click on the P icon for pick device window to set the components. This is the pick device window. In pick device window, set the component relevant key names. Set the required component using relevant key names. So my requirement is two different components. First one is microcontroller, then after next component is LED. So I give the name, controller name 8089C51. It is a microcontroller name. So first one is our microcontroller. So once you double tap on the microcontroller name, it automatically added to the device list. Check once. It is added to the device list, right? And same way, second component is LEDS type check. You just type the LEDS. So you type the LED, so many components in the section, right? But to short of the shortcut list, you just type the S. LEDS. So in the LEDs list, only select the animated type. Only 8 LEDs is there. So based on the color, blue, green, red, and yellow. So only 4 different colors are available. So select any one of the LED. So my suggestion, I'm selected red color LED. Okay, the red color LED. So 2 components is sufficient. So once you select the required components added to the device list, just close the pick device window. Just close the pick device window. So then after, place the required components on the design sheet. It is a design sheet, guys. Graphical page is a design sheet. The required components in device list. Now select the component and place the component on design sheet by using left click only. Okay, and same way, select the LED and place the LED. Right. You can use any port, guys. The microcontroller have 4 different ports, right? So I'm zoom the components, so and adjust the project area. I mean design sheet for visualization purpose. Is it clear? Is it clear, guys? Next one, you choose any one of the port to connect to the to interface your LED. My suggestion, I given the port 2 because visualization is best to interface any component to the port 2, right? So in port 2, I'm selecting the first pin, port 2.0. The port 2.0 is connected to the anode pin of LED. Anode pin of LED, and the cathode pin is connected to the ground. How to take in the ground? From first you select the mode is thermal mode. The mode is the component. Electrical component is ground, right? So the ground is available only thermal mode. So select the thermal and select the ground, right? So now once you select the ground, and next one place the component using left click and connect the component through terminal using wire. So based on the connection, what are the requirements? So once you turn on the LED, it required 1. It required logic 1. To turn off the LED, SN 0. So in this case, we are operating anode pin. We are operating only anode pin. So cathode pin is fixed connected to the ground. Is it clear, guys? Is it clear? So cathode pin is fixed with ground and operating only anode pin. So to turn on the LED, SN logic 1. So SN logic 1 to the port 2.08 pin to turn on the LED. SN logic 0 to the pin to turn off the LED. So based on the connections, these are the requirement to operate the LED. Is it clear, guys? Is it clear or not? Just I'm waiting for your confirmation. Do you understand the points? What are the required points? Yeah, right. Okay, fine. And next thing, so hardware connections is over. For testing purpose, we require an executable file. To generate the executable file, open Kill software. So in Kill software also same thing. So first thing, you create the project. So how to create the project? So in project menu is there a menu bar. In menu bar, project menu is there. So just click on the project menu and select the first option, that is new microcontroller project, because it is a new project, right? So that's why we are taking the new project. So once you select the new project, it will show the a pop-up window to save the project and assign a suitable name to the project. 2 things. First we need to set the path where you want to save the project. So we already created the destination path, that is on desktop. So I'm selecting the desktop. Next one is select the path, main folder, that is LED blinking, right? So I'm selecting the folder. Then after give the suitable name to the project. So here I'm making blinking. Just we give the name is blinking, right? Blinking. So once you given the suitable name to the project, then after just click on the save button to save the project. So once you save the project, then after new pop-up window for to select the target device, which one you want to develop your project, right? Component. So that this is a family members, different families. So these are the different families, like your surname. So in surname base, you select the particular person. So I'm selecting the surname Atmal and split the Atmal family members. So once you split that, these are the family members, right? So in the family members, I'm choosing the microcontroller 8089 C51. Once you select the target device, just then after you click on the OK button. So next third step is one pop-up message there to copy the startup file to your project. So just give me confirmation, yes or no. There is no requirement to add to this file to the project in 8051. So your choice. So right now, yesterday I selected yes. Right now, I'm saying choose the option no. There is no difference between the selection of yes or no. And next thing, to write to give the action, you are required instruction to the microcontroller. We required our text file and write in code in C language, right? So to add the text file, so select the source group and right click on the source group. So action. So yesterday I'm using add existing file. So first take in one text file and write the code on it and save the .c file. Then after add it to the source group. But right now I'm using the first option, add a new item. Add new item. So once you select this option, you got the one pop-up window to select the file type and give the suitable name to the project file. So I'm just selecting it is a C file, right? It is a C file. So I'm selecting the C. Then after, give us a file name. So file name is blinking. There is no dot actions. Okay. Just click on add. Once you click the add button, the C file is added to the source group and save in the same folder. Right. So split the source group. So the blinking LED.cc file is also added to our source group. Right, guys? Right. So what is our main agenda, guys? What is our main agenda? To blink an LED, right? To blink the LED. So initially, observe here, guys, I'm running the project file. Initially, the LED is on state. Initially, it is on state, right? Because of the initially, the pin is active high state. That's why the LED is on state. Is or no? So that's why. So to turn blinking means what is the meaning of blinking? Initially, it is on. Next step is off, and then after next step is on. So blinking means it continuously on and off, right? So first thing is LED equal to 0 because to turn off the LED, SN logic 0 to the LED, right? Next thing is to turn on the LED, SN logic 1 to the LED. Remember these 2 points, guys. First step is to turn off the LED. Turn off LED. Next one is turn on LED. Guys, do you understand the point? So LED equal to 0 to turn on the LED. LED equal to 1 to turn on the LED. So the microcontroller write these two statements, it will take around 2 microseconds of time. Around 2 microseconds. The capability to write the data to the LED, it will take around 2 microseconds. But The LED responds for input. You write this information to the LED. It will take around milliseconds of time to respond your input. It will take around milliseconds of time, 10 milliseconds of time. But my human being understands the observation. It required also at least worst case is 10 milliseconds. At least is seconds, right? Yes or no? Yes or no? To identify the LED is blinking, it will take around to find out the it blinking. To observe the blinking, it will take around seconds of time. Yes or no? So to provide the delay between the both intersections, delay between the both two intersections. So once you execute the LED equal to 0, then after maintain some delay. So delay. So that delay function provides the 1 second of delay, assumption, 1 second of delay. So then after maintain also delay. Right guys? So first LED is off. After it maintain the 1 second of delay. And next step, turn on the LED and maintain the delay. 1 second of delay. Again, move back to the 6th line. Right? Yes or no? If blinking means it continuously on and off, right? Yes or no? Blinking means it is continuously on and off. Yes or no? Yes or no, guys? Please respond in chat box. Do you understand the point or not? Blinking is means on, off, right? It is continuous procedure to play on and off. Yes or no? Right? It is a continuous procedure. So to repeat the same operation multiple times, how to repeat the steps? By using loops. Right? Good. So you are using while loop. So while loop to repeat these steps. Right, guys? To repeat these steps, you are using while loop. So once how to repeat how the delays works? Only 1 second. So I'll explain the definition of the delay. Don't worry. Just now observe just it provides the 1 second of delay. Once to define the delay subfunction, I will tell you how to provide the delay. To repeat these steps, 4 steps, you are using while. The condition is how to use the while loop, guys. It has a condition. Once the condition is satisfied, it repeats what are the statement. It executes what are the statements between the braces. So my agenda is these statements. What are the passing the 4 statements? It continuously executing 4 statements, right? So that is the main condition, right? So to maintain the continuous execution of these 4 lines, you give the condition is 2 statement within the parentheses. What is the 2 statement, guys? Except 0, you provide any type of data within the parentheses. Within the parentheses, you can provide any data except 0. You type 1, you type 10, you type the 1 or 2. It is a value, constant value. It is a true value, right? And you provide the character also. Don't worry. And it provides the name also. Basically, guys, you paste any character, any string, any integer value, any character, right? So it is a true statement, right? It compared to you pass a single operator within the braces within the parentheses. It compared to 0. You just provide a single operator. The comparison will be taken that to require two parameters, right? But you pass the only single parameter. When you put in a single parameter, it compared with 0. And compared with 0. So based on our loop, it executes in these 4, right? So before you see our compiler these 4 steps, you must use the main. So it is an indication. Compile. It is a main is the indication to the compiler starts from here. Where you want to compile the program, just it is an indication. So void main. So in void main, void is the indicator. Void is also an indicator. What is the indication? There is a not a written variable, written data, written anything. Okay, there is a no written. That is the indication of void. So main is the indication, guys. So main is the indication. To main is the indication to indicate to the compiler. Start the compilation from fourth line. Is clear, guys? Main is the keyword. Main is the keyword. It is indicated to the compiler. Starts from this line. So only these statements, right? And next thing is we are using one function. We are using one variable. Remember, thing, guys. We are using delay function and using one more variable, that is LED. This LED, what is the delay? So you must mention the declaration is there. So user function declaration. User function declaration void delay. Void delay. So void delay user function, guys. Void delay is the user function. So which type of function is there, guys? We are using which type of function? Void delay is a which type of function? Void delay is a which type of function? Did you understand the point? Which type? In user functions for yeah, right. In user, 4 different type of functions is there, right? So right now we are using no return, no argument. No return, no argument. Right. So next declaration is next declaration. So LED. What is the LED? It is a variable name, right? It is a variable name. What is the LED? So it is a name assigned to the particular pin. How to assign the variable name to the pin? So just using a syntax is sbit. So what is the meaning of sbit? Bit. Yes, sbit. So sbit means a single bit of memory is assigned to the variable. Only one bit of memory is allocated to the variable. That's why you using syntax is sbit. So sbit. So variable name LED. So what is the address of port 2.0.08 pin? Right. So you are using LED name is assigned to the port 2. In port 2, pin number 0th pin. That is the meaning. So assign that particular pin to the variable name is LED. So you call in this entire program, you call this port 2. What is the meaning of port 2? What is the meaning of printf? What is the meaning of scanf? Those information is available on header file, right? And same way, the meaning of port 2 0 is available on header file. So what is the header file of 8051? The header file of 8051 is #include within the curly brace, within the braces, you must type your header file name. The header file name is regx51.h. It is a header file of 805. It is a header file of 8051. So in this entire declaration is over both pin and user function. And users also completed. But what is the definition of user function? You have missed the definition. So what is the definition of delay function? So next one, the definition of user function is void delay. Void delay. So within the braces, within the function, what happened? So from instructions, suppose it will take around 1 microseconds of time to complete the single instruction, right? Yes or no? How much time it will take to complete the single instruction? It will take around microseconds, 1 microsecond, right? So how many instruction to completed within the 1 second? Guys, please respond. how many instructions completed within the 1 second? Please respond, guys. 10 to the power of 6. So 10 to the power of 6 means 10 to the power of 6 means around, what is the value? 10 lakhs, I think. Is that no? Right. So what is the capability of integer? Just int. What is the maximum? Worst case? In worst case means maximum number, possible number for integer data type. 65,535. Not 45, it is a 35. Right. So it required value is 10 lakhs. That's why I am taking the splitting operator. Splitting operation. So for splitting operation purpose, we are using int. Int variable data type. So you declare two variables. So a comma b. Required to provide the multiplication operation to provide the 10 lakhs of instructions, right? So it is a continuous procedure. Some blind operation, purpose, we are using for loop. So for a equal to 0, starts from 0. Our loop is starts from 0. And next worst case, a less than 1000 because of 10 to the power of 6 dividing into two partition, two loops, 10 to the power of 3 plus 10 to the power of 3. Right? For 10 to the power of first for loop, second for loop, 10 to the power of second for loop. So a plus plus. Then after second for loop, for b equal to 0 and b less than 1000 and b increment. The function is over. This is a long software delay. Simply says it is a software delay. It provides the assumption of 1 second delay of delay. It is assumption, not exact delay. If you need exact delay to blink the LED, you must use the timer concept to provide the delay. It is a software delay. It is an assumption of delay. Is it clear, guys? The program is over. Check any syntax errors in your program. I'll just compile the program. Building. So there is a warning. One warning is there. What is the meaning of warning? Uncalled segment, ignore the overload process. Blinking. Blinking, delay. It's okay, fine. There is no errors. So then after convert the C program, it is right in the C program, right? We give the two instructions to these two instructions is required the remaining things. This information is in C programming, right? Next, this C program is converted to execute file. Execute file. How to convert to the execute? How to generate or update or create the execute file? Three things, guys. So we are generating the execute file from project only project. So that's why we select the target. I right click on target. This first option is there. Option for target. First option is there. Option for target. Once you select the option for target, it opens a window, new window. In a new window, you must select output. What are the output of your target? So you select the output of target. It should observe here debug information, browse information. These are the outputs, right? Here, one more option is there, create hex file. It is a execute file. Execute file means it is a execute file. So initially it's now unselected. Initially the checkbox is unselected, right? Now need hex file, you select the checkbox. Once you select the checkbox, just click on OK. The modification is over, done. Next one is to generate the file. So to generate the file, rebuild your project. After any modification, don't forget or rebuild your project to update the modifications based on the modification, right? So rebuild your project. So the creating XML is done, or is the main agent of kill is done, completed. So next move back to the Proteus. Move back to the Proteus. So start the simulation using fourth icon. It is stop the simulation. Next, the generate file is available on the inside the project folder, right? Inside the project folder. So the file is a path set to the microcontroller. For simulation, in the simulation, first select that file path. How to select? So right click on the microcontroller and there is option for to edit the properties of my microcontroller. So edit properties. Once you select that, again open the new window to edit the properties of a microcontroller. In that window, you paste the path of file path of our exe file. Just paste here. Otherwise, to navigate to select the file, folder icon is there. So just click on the folder icon. So what are the files is available in project folder? Therefore, it is visible on the window. So select the execute file and click on OK to set the path. Up to here, the path is blinking, right? So once you have modified that, save the modification, just click on the OK. Once you root the file, execute file root to the microcontroller, then start the simulation. Then after you start the simulation, you observe the output. So it is executing or properly. So start the simulation. So observe the output. Initially off. So next thing, turn on the LED. It will take some extra time. I think it is a assumption of delay, right? So it's on. Again, off. So it is taking the more time. So that's why I'm remove the 10 for fast blinking purpose. Save the file and rebuild project. Any modification on the kill. After modification, you must check the syntax errors. Then after rebuild your project for updating the hexa file. So once you done the updated hexa file, stop the simulation and again start a simulation. After here, guys, LED is blinking. It will take fast delay. Right? The delay is completed. A blinking LED concept is completed, guys. Then after last step is to save your file, your current file. So file, save project. So to save the last modifications. So the concept is over, guys. If you have any doubt regarding blinking LED concept, just put in the message in chat box. Otherwise, left from the meeting, guys. If you don't have any doubts, just left from the meeting.